Hey guys, it's Mrs. B again. Today we're going to be working with reviewing scatterplots and what we do with them and what information we can get with them. Now this is going to be loaded for pre-algebra, but it can also apply to Algebra 1. So either one of you can look at it. Matter of fact, I think I did the exact same work with both groups, but I can't remember when we did this earlier in the year. But primarily what we're going to talk about today is what a scatterplot is, what it looks like, what we can get just from the basic information, like correlations. Is it trending positive? Is it trending negative? Does it show no trend at all? And then kind of looking at how we can take that information and then figure out or estimate a line of best fit or an equation of a line that goes through it that pretty much lets us predict what possible values could come from our scatter plot. So we're going to get started with a few things. We're going to start with our definition of what a scatter plot is. And I've seen good ones over the years, and I think y'all have a really good one in your notes from earlier this year. But a scatter plot is basically a visual representation of our data in a coordinate plane. So we're going to use ordered pairs. Okay, now we have three possible what we call correlations or relationships. Scatter plots can pretty much appear one of three ways. They can appear to have a positive correlation or an upward trend, a negative correlation, or a downward trend, or no correlation at all. And what that means is it pretty much looks like your little brother or your little sister grabbed the Skittles and just threw them all over the table. And there's no real anything that you could do to tell anybody about this other than they're scattered all over everywhere. Okay, now, when we are looking at scatter plots, let's look at this. Here's some questions. It says, determine a type of relationship most likely shown by the data. The size of a home versus the size of its lot. Now, does that have any kind of correlation? Well, let's think about it. My house is a 3-bedroom house. It sits on 4 acres, okay? So I've got a pretty small house, a nice size lot that it sits on. You know, I have a friend who lives in Danville. They have the same size house, but their lot is not very big at all. You can barely get by the sides of the house. And they've got a little bit of a backyard, but we're talking maybe 1/3 of an acre. Okay, not that big. My dad, when he was alive, lived in the DC area. His neighbor, the houses were side by side by side, and you had a little postage stamp yard in the front, a little postage stamp yard in the back. My dad had a 2-bedroom, 1.5 bath little condo, smaller than me, but also smaller yard. Some places don't have a yard at all. If you live in an apartment building, you don't have a yard at all. But if you go to New York City and you have a penthouse, you have an apartment bigger than my house with no yard at all. So is there a relationship between the size of your yard and the size of your house? Not really. Okay, the number of passengers on a plane versus the number of suitcases. Now, I don't know how many of y'all flown before, but I fly about once a year. I go to a conference every year. This year it got canceled. But what happens is you're allowed one suitcase, one carry-on, pretty much. You can bring more than that, and some people do bring more than that. But there's usually as many suitcases, as many pieces of luggage on the plane as there are people on the plane, sometimes more. So the bigger the plane, the more people you have on the plane, the more luggage you're going to have. So if I have 5 people, I probably have 10 suitcases. If I have 30 people, I probably have 60 pieces of luggage. So I can kind of predict and estimate. This one, the more people you have, the more luggage you should have. So this has a positive correlation. Okay, the number of days in fall versus the number of leaves on the trees. Let's think about this. When October comes, the leaves start changing. Middle of October, half the trees have leaves, half the trees don't have leaves. Are we further into fall when we get to the middle of October? Think about your yard by Halloween. How many trees still actually have leaves in your yard at Halloween? Not many in my yard. And that Halloween is a full month into that fall. So the further into fall we get, the fewer leaves we see on the trees. Now, is that a positive thing or a negative thing? If I were to graph that out, is that line going to go up from left to right or down from left to right? It's got a negative correlation because it goes down from left to right. Now, is it nice to see questions as simple as that? To look at a picture and decide the correlation? Yes. But is that always how we end up doing the problems? No. So now let's look at a problem where we actually put all this into place. Now we're going to have to remember how to graph ordered pairs. And when we pull them from a table, the ordered pair, the x coordinate comes from the first column, the y coordinate comes from the second column. And what we're going to do is we're going to have to decide how they go on our graph, and then we're going to see what conclusions we can make. Well, because I decided that the first column was x, that means hours is going to go down here. And the second column is y, means grades are going to go here. So I've got anywhere from 1 to, looks like 8 hours that people spent studying. So if I try this, we'll call this 0 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got enough room to do that. Grades, I went by ones down here, but you've got to go from 0 to 100 with grades. So what are you going to do? I think I'm going to do this in, see how many I've got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to do this by 10. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now we're going to have to do a little estimating here because, you know, not all of them are on the zeros, but let's look at this. First person took 3 hours to study and they made an 80. So I go over to 3 and then up to 80 and I put a dot. Then I've got 5 hours studied and a 90 on the test. Over to 5, up to 90. 2 hours spent studying, they bombed the test, they made a 45. So that's 2 and 40, and then halfway would be 45. 6 and 85. So that's not a bad return on their investment. 8 and 95, somebody spent a whole lot of time studying and it paid off for them. 1 and 55, 2 and 60, 7 and 100. Ooh, that really paid off for them. and 4 and 75. Now, if we just look at this picture, what can we say about the dots? Are they heading in a positive direction? Are they heading in a negative direction? What conclusions can we draw about this picture just from what we've put on it? Well, if you look at it, it's kind of going up. It looks like the more time I spent studying, the better grade I had. So this has a positive relationship or a positive correlation. Okay, now, so that's part of the deal. Once we get it graphed out, we look at it and go, okay, is it trending up? Is it trending down? What's it doing? The other part of this is actually writing an equation for our line of best fit. So that changes, it doesn't change what we do, it just changes how we look at it a little bit. The line of best fit is the line that closest represents our data. Okay. Now, on this, we're lucky. They gave us our scenario already. They have already graphed it for us. So now let's look at what is going on with it. Is this heading uphill or downhill? Well, if I look, it's pretty much headed uphill. This has a positive correlation. Okay. Now, if you look over here, all our equations are written in slope-intercept form, y equals mx plus b. And the part we want to look at right now is m, is the slope. Okay, so let's see. So I'm going to look at 2/3, 3/2, okay? Now, first thing I want to look at when I've got options like this, if this is heading in a positive direction, my slope needs to be positive. Well, when I look at this, that doesn't help me eliminate any choices, does it? Because all of these are positive. The next thing to do is to actually graph each one of these lines and see which one actually best describes my information. So I'm going to start out with this first one. 2/3 as a slope means once I get my first point on my graph, I'm going to go up 2 and write 3. This plus 50 right here means that I start out from the ordered pair 0, 50. This is my y-intercept. This tells me my easiest starting point for my line. So let's look at this. I'm going to go to 0 and 50, and then I'm going to go up 2 and over 3, up 2 and over 3, up 2 and over 3. Now, once I have those, I'm going to go ahead and I'm going to sketch my line and see, does it match my information? Well, kinda. It's close. It's not perfect, but it's close. So that's a possibility. Let's look at the next one. The next one has the same y-intercept, but it has a different slope. It has a slope of 3/2. That means I'm going up 3 and right 2. So I start from the same place, but this time I go up 3 over 2, up 3 over 2. Well, let's check this one. Does this one do what I want it to? Or am I going to eliminate this as a choice? Oh, that definitely does not come close to any of this stuff right here. So this line right here is definitely not an answer choice. So A is still in the running. B ran way too far away from the remainder of my data. So let's look at the next one. The next one has a slope of 2/3, which means up 2 and right 3. But this time my y-intercept is at 55 instead of 50. So that means I'm going to start from the point 0 and 55. Well, 0 and 55 is here. Now we're gonna count out our slope. Up 2, right 3. Up 2, right 3. Now let's trace it out. My graph's getting kind of crowded here. So here we go. Well, that one might even be closer than my first one. So line C is still in the running. Now let's look at line D. Line D has the same y-intercept as line C, but its slope changes. The slope here, it means up 3 and right 2. So let's see what we've got here. I'm going to start at 55 and I'm going to go up 3, 1, 2, 3, and right 2. Up 3 and right 2. Well, if I look at that, that is way, once I get my line drawn, let me get my line drawn. That is seriously far away from where I want to be, isn't it? That's definitely not going to work. So now I have to decide between line A and line C. Well, if I look at it, which one more closely gets, which one gets closer to more points? Line C or line A? The answer here is line C. Okay. Now, that's nice if we've got a multiple choice question and we're kind of looking for it. And guys, this is a lot of what's happening now when they're doing a lot of the trends and things that they're doing right now when they're looking at COVID-19 and the current crisis and getting supplies where they need to be and all kinds of stuff. Analyzing data like this with scatterplots is part of what the scientists and the politicians and all those other people are using to figure out what's going on and what needs to be done next, okay? So if I look at number 1 down here, our instructions say we're going to draw the line that closest matches the data. You're going to find the slope and the y-intercept and then write it in slope-intercept form. That's what these instructions say, and that's pretty much straightforward what we're going to do. But for me, when I look at a scatter plot, the first thing I want to do is I want to look at its trend. Is it an upward trend or a downward trend? Is it a positive slope or a negative slope? If I look at this, this is headed uphill. This has a positive slope. Now, I'm going to kind of want my line to sketch right through the middle of this. So I need to figure out a way to tell somebody about that. Well, for me, I got lucky this time. Right here is my y-intercept. I'm trying to fill in y equals mx plus b. And right here, that point right there where it crosses the y-axis, that's my y-intercept. That's my b. So that part's easy to put in my problem. So that is, let's see, this is 10 and that's 16. That means this is making jumps of 3. Maybe. Yeah, it's making jumps of 3. So 10 minus 3 is 7. So this is something plus 7. So the thing I don't have right now is the slope. Now we have to remember, this number is talking about what this line is doing in terms of getting from point to point. So I need to know how many steps up and how many steps over I had to take to travel from this point to any other point on this line. Well, since I'm kind of sketching this line right here, I'm going to estimate, and I'm actually going to use that point right there as my ending point, and this is my starting point. Slope, if you remember, slope is always rise over run. Let me find a good place to put that. Slope is always rise over run. So that means our up and down is on top and our left to right is on the bottom. So if I look at that and I start here, I'm going 1, 2, 3, 4, 5, 6 boxes up. But each box represents 3. So if I'm counting by threes, that's 3, 6, 9, 12, 15, 18. So for my slope, I went up 18. Now along the bottom, let's see. It's going by ones along the bottom. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 to the right. Up and right are both positive. So this is 18 divided by 11. So the equation, the rough estimate equation of my line of best fit is y equals 18 over 11x plus 7. Now, the next part of it is probably sometimes for most of us the hardest part to wrap our head around. It says, estimate the weight of a baby that is 12 months old. What that means is this 12 is going to be our x. And we're going to take y equals 18 over 11 times whatever x is plus 7. Well, if that's 12, I have some math I've got to do here. So I'm going to take my calculator and I'm going to do, let's see, 18 times 12. Then I'm going to divide that by 11. And I get 19.636, and then I'm going to add to that 7. So a baby that's a year old, based on this chart, should be approximately that much. So it should be approximately 26.63 pounds. So y is approximately 26.63 pounds, and that's a repeating 6-3 there. So this is kind of how we work our way through these. Now that's the end of what we're working on today. If you have any questions, please put them down in the comments. You know, as you look through the rest of the packet that you can download from the Google Classroom for our class for this week, April the 3rd, the week of April the 3rd, you know, there are more pages in this packet for you to do. There are more practice things, but this packet contains mostly box and whisker plots and scatter plots, so, and just drawing conclusions and estimating things about them. I hope this was informative for you. If you have any questions, please feel free to add them in the comments. I'll reply to them as quickly as possible. As a reminder for my students, I am keeping office hours from now until the end of the school year from 9 until noon every day, Monday through Friday. Be safe, be careful. I love you guys and I miss you, and I'll see you soon.